This is a series of multiple choice past paper questions on the AQA A-level chemistry topic of alkanes. There's 5 questions in here and we're going to recommend you pause on each one and then review the solution once you've tried it. So with that in mind, here is the first question. So on here, what we're looking for is a propagation step. Now, in a propagation step, we start with a radical and we end up with a new radical. So if we now go through and highlight where the different radicals are, I can see I've got 2 on the left here, 2 on the left here, 2 on the right here, and 1 on either side here in D. So if I were to actually assign those, these are going to be termination steps where 2 radicals combine to make a non-radical. This in C is an initiation step where 1 compound has broken down into 2 radicals. And that therefore means that D, where we start with 1 radical and end up with another, is the propagation step. Correct answer is D. Next question for you. And this is actually a good opportunity to look at some wider chemical knowledge as well. Which of these is correct? Well, the fractionating column is hottest at the top. That's definitely incorrect. It's hottest at the bottom and there's a cooling gradient as you go higher up. If I then move up to gaseous fractions formed by breaking covalent bonds, we absolutely don't break the covalent bonds. We overcome intermolecular forces, the forces between the molecules. Those forces get stronger as the chains get bigger, and that's why melting and boiling points get higher. If I go to A zeolite catalyst is used. This is quite a common potential error because people do tend to put together cracking and fractional distillation when they're not so confident. Zeolite is used in cracking. Cracking is where longer chains are broken down into shorter chains. Fractional distillation is where we separate out the chains. So, correct answer is B. Each fraction contains a mixture of hydrocarbons. Petrol, for example, is not C6H14, but it might contain C6H14, C7H16, and C8H18. Okay, next question. And similar to the first one, but this time we're looking for a termination step. So we've got termination. Let's highlight all of the radicals. I can see here, I start with 1 and end with 1. I start with 1, I end with 1. I start with 1, I end with 1. I start with 2 and I end with none. So the first 3 of those are all propagation. The final one, D, is termination. So the correct answer is D. Next question. Okay, and for this then, we are looking at part of a wider mechanism. Which equation is a propagation step in the conversion of trichloromethane into tetrachloromethane by reaction with chlorine in the presence of ultraviolet light? So we want propagation. So let's have a look at if that narrows this down at all. Well, it's certainly not A. A is not a mechanistic step. This is the overall equation to go from trichloromethane to tetrachloromethane. So that can't be the right answer. B also can't be the correct answer because I've got 2 radicals forming a non-radical. It's a termination step. So I'm left with C or D. Now C and D are both propagation steps. However, something that is very important to recall is that we don't ever really deal with H radicals. So that dismisses that one. And what we then see is this step. And if you're familiar with the free radical substitution mechanism, you will then recognise this as one of the key propagation steps in that route from methane all the way to tetrachloromethane. Next question for you. And there's a huge amount of factual recall here. You've simply got to know what the conditions are and what the products are for the 2 different types of cracking. So let's go through first and look at the temperatures. All of these are at a high temperature. We've not disregarded any now because thermal and catalytic cracking both take place at high temperatures. If I then move on to look at the pressure, well, thermal definitely takes place at high pressure and catalytic at a slight pressure. So that's the fundamental difference between them, the advantage, I suppose, of using the catalyst, because it does bring energy costs down. But that does mean that we can disregard B and D. We're now down to a 50-50, A and C. Well, for A, it's simply not correct to say that thermal cracking produces mainly alkanes. Catalytic, however, does produce mainly branched alkanes and aromatics, so the correct answer is C. That takes us to the end of this video. Thank you for listening and goodbye.